Hey everybody, back with another Polars tutorial. Hope you're all doing well. And today we're going to be talking about one of the more peculiar implementations in the Polars library. I say peculiar because I haven't seen this implemented in a similar way in other technologies I've used in the past. And that's the LazyFrame and the lazy mode API in general. And so LazyFrames are basically the flip side of data frames. And so, I mean, to back up a little bit, Polars, its big selling point is just speed and efficiency. It's all about using big data. It's all about optimizing your code. It's all about running things really, really fast. And lazy mode is just an additional tool you can use to make your code run just really, really fast as possible. And so that begs the question, what's the difference between a data frame and a lazy frame? It's pretty simple. So a data frame contains data, rows and columns, just like we would think of it. And this is the part that's like kind of interesting and maybe hard to wrap your mind around at first. A lazy frame doesn't contain any data. So in other words, when it sees the data that you're trying to load into the lazy frame, it doesn't immediately read it in. Rather, what it does is it scans your data and it gets some high-level information like the column names and the data types. Very, very basic information like that. And then it's going to scan your code and it's going to develop a query plan. And so it contains two things, a scan of your data and then a query plan, which is based on a scan of the actual code that you want to run over that lazy frame. And so that also begs the question, like, so what's a query plan? What's all this about? And so there's four characteristics of a query plan. I may be missing some, but this is just kind of what I've noticed in my work with the lazy mode API. And so the first characteristic of a query plan, or just one thing that's important to understand, is that the lazy frame will not run your code immediately. It's going to scan your code, but then it's also going to do something else. It's going to scan your code, determine what the result is that you're going for, and it's going to optimize what you do. So if it sees a lot of redundant processing steps, it's going to either remove those or combine those into one step. If it sees you doing kind of an inefficient join, it's going to do a different join for you. And so what you, get out of here. And so what you write isn't necessarily going to be what you send to the processor. What gets sent or what actually gets executed is going to be what the lazy mode editor does for you. And so the result will be a lot of processing steps will be rewritten into a single query. And so that's another thing. That's another aspect about it that I've noticed. It abstracts everything you're trying to do into a single processing step, which is fairly incredible. And then the final thing about it is that you have these lazy mode queries. They're kind of useless to you unless you can run that query over data and actually get a real data frame at some point. And so you execute your query plan with a method called .collect. And what collect will also do is it will materialize your lazy frame into an actual data frame. And remember, a data frame is the actual variable that contains rows and columns, which is in the end what we would eventually want. So what we're going to do here in this program is I just created two little data sets here, two lazy frames. And the way we create a lazy frame is instead of writing in data frame, we write in lazy frame, and then we'd enter the data just as we normally would. And so I have a couple of sample columns here, and so an ID column, a time column, and then in the second data set, df2, an ID column and just a column for sex. And what we're going to do is we're going to write some redundant code over this first data frame, and then we're going to join it with this second data frame and create a third data frame out of that join. So pretty simple, but I think this will show us pretty clearly how the lazy mode operator works and just kind of what it does. And so here's our redundant code that we're running over this first data frame we created here, df1. And so we're just creating these columns, new call 1, new call 2, new call 3. And this is redundant because we don't need separate processing steps for this. We could just write this in one processing step. So like this. And so on. So having these spread out into 3 different processing steps is a little redundant. And so we'll take a look and see what the lazy mode editor did with this. But first, so it's scanning our code. What does does Polars or the lazy mode API actually do when it stores our code? And here's the join we do. So let's just do a print. So what it stores is, again, the query plan, but it stores two things. It stores A, the naive plan, and then also the optimized plan. And so let's take a look at what the naive plan looks like. So if we just print df1, if this were a data frame, we'd get like a table with rows and columns and all that. Let's take a look at what happens when you just print df1 just in its current state. Okay, so here's a printout of the naive plan for df1, and we can see indeed there are 3 with column statements. And we see it creating our columns here: new call 3, new call 2, new call 1. And the input data is this data with an ID column and a time 1 column. And so that begs the question, like, okay, that's the naive plan. How do we get the optimized plan? In other words, how do we see what the lazy mode editor is actually doing with our code? We can get the optimized plan for each of these data frames using the .explain method. So we just run a print and .explain over these. We'll be able to see what the lazy mode is doing to our code. Whoop. And the results are actually quite interesting. Okay, so here is the optimized plan for our first data frame, and you'll see right here in the naive plan we had 3 with column statements being executed. Here in the optimized plan we have only 1, and within this processing step all 3 of those variable initializations are just being done in the same step. So again, what it did is it saw the fact that, you know, we're doing this data manipulation across 3 steps. It noticed that this could all be done in 1 step, and it made that optimization for us. So pretty incredible that it can do that. And then for df3 right here, where we're doing the join between df1 and df2 on this ID column, if we look at the optimized plan for that variable, you'll see something even more interesting. Or for that data frame, you'll see something more interesting. So you'll see here that it's doing this code for an inner join. And so for the left-hand data frame, so the left-hand data frame in this join is df1. So for df1, so it actually does the with column statement, so the variable initializations that we did, at the same time as the join. So in other words, it saw the fact that we were doing this variable manipulation up here, and it said, okay, we can actually do this at the same time as this join. And it actually brought that into this processing step. And then it joins it to this into the right-hand data frame, this df2 data set. And so again, to create an actual data frame out of these, we need to use the .collect method. But then that begs the question, like, well, which lazy frames do we want to collect into actual data frames? And that's an important question because, again, each of these lazy frames that we have, they contain a query plan. In other words, they contain code that's going to get run. So, I mean, the goal with an efficient project is that you want to run as little code as possible. And really, in this case, the only data frame we'd want to materialize into an actual data frame is this df3 column, because it contains not only the join, but the variable manipulation too. So if we were to run collect on the first data frame we have, we'd be just doing a lot of redundant stuff. You know, we don't need to create these new columns a second time because they're already being created in this query plan for the third data frame. So we'll just go ahead and run collect on df3 and we'll print that out. Hey, all right, so there's our data frame. There's our columns that we joined together. There's our new columns that we initialized. And we see that our data frame is no longer a lazy frame. It is a data frame because it no longer contains a query plan. It contains actual rows and columns. So at this point, we could use our data frame as just like a completely normal data frame and not worry about the lazy API after this. But yeah, so that's how you use the Lazy API. It's a pretty incredible tool. I'd say just the main challenge, like I said above, or at least the thing I find most challenging, is figuring out which LazyFrame to run collect on in such a way that you're not building any redundancies into your program. But so that's all for LazyFrames. If there's anything else you'd want me to cover on this topic, feel free to write so in the comments. But thanks so much for watching again, and I'll talk to you next time.